You've already learned how to solve quadratic equations by graphing and by taking the square root. The graphing is very useful if you're around a graphing calculator. Square root is great if you don't have a bx term. We're now going to learn how to solve by factoring. This is great if the equation is easy to factor, like the examples we're going to try now. Follow the step-by-step directions that you wrote in your journal the other day. Step 1 would be to equal the equation to 0. That means we'll need to subtract the 45 to the other side. After we can equal it to 0, we want to factor the quadratic equation. Now you've been working on a factor packet with all types of factoring. This is an easy trinomial. In the front we have x and x. In the back we need to think about what multiplies to 45 or negative 45 but adds to negative 4. We're going to use factors of 45, 9 and 5, and if we do negative 9 and a positive 5, yes, they will multiply to 45 and they will add to negative 4. So let's place those factors in our parentheses. Once it's factored, we're going to use the zero product property. That says we next take each of our factors and make them equal to 0. Because one or both of these must be equal to 0 for the whole thing to equal to 0. You're then going to solve these mini equations. I can add 9 over, and then I can subtract 5. So my solutions are 9 and negative 5. If you were to graph this, you would see that the parabola crosses through the x-intercepts at 9 and negative 5 as well. Let's look at example 4. In example 4, we're finding the zeros of the function. This is the function. If you're finding the zeros, that just means equal it to 0. And we're going to solve like we did example 3. We're looking at the quadratic here, and we're going to solve by factoring. You should always check for a GCF first, like can you take a 2 out? We can't take a 2 out. That means that this is going to be a harder trinomial. Before you think that it's a harder trinomial, you should also see if it's a special trinomial, like difference of two squares, or a perfect square trinomial, but it's neither of those. So for the harder trinomial, many of you know different methods on how to solve this. I particularly like guess and check. So I'm going to guess what makes 2x squared, and that would be 2x times 1x. So that's what's going in the front of my parentheses. Then I'm going to guess what multiplies to 12. I could use 1 and 12, 2 and 6, or 3 and 4. So I'm going to take factors of 12, multiply them to the factors of 2, and somehow get 11. So I could do 2 times 3 and get 6, and 1 times 4. That would be 6 and 4, which makes 10. That does not work. What if I did 2 times 4 and 1 times 3? 2 times 4 is 8, and 1 times 3 is 11. Or 1 times 3 is 3. 8 and 3 together make 11. So that's going to work. What I need is the 2x times the 4 and the 1x times the 3. From here I need to check my signs. I need a negative 11. So if I have a negative 3 and a negative 8, that would give me negative 11. So I'm going to put negatives here. So I'm thinking this is my factors. I would probably double check by foiling again. 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x. And then negative 3 times negative 4 is positive 12. When I add these like terms, I do get my trinomial back, so I know I factored correctly. Now I know that takes time, but as you practice, the guess and check method will get easier. From here, we're going to take each of our factors and make what I call mini equations. Make each factor equal to 0, and we're going to solve. Now the one on the right is very easy. You're going to add 4 to the other side in your head and get x is 4. This side, we're going to add 3, but then we need to divide by 2. So x equals 3 halves, or 4. Now 3 halves would have been difficult to see on a calculator, and we definitely could not have factored this using square roots because we had a bx term. This is solving by factoring. You definitely need to have your factoring skills ready before trying to solve by factoring.